What if everything we thought we knew about the beginning of the universe was wrong? Not slightly off, not a rounding error, wrong in a way that changes everything. Right now, the most powerful telescope ever built is staring into the oldest corners of space, and what it's finding is making the world's greatest scientists quietly panic. Galaxies that shouldn't exist. A universe expanding faster than physics allows. Objects so strange we don't even have names for them yet. This isn't science fiction. This is what's actually happening, and nobody has a clean explanation. So what exactly did Webb find out there? And why does it matter so much? Let's find out. Welcome to Astrion X, where we go beyond the headlines and into the deep end of the cosmos. If you're new here, this is the place where the universe stops being background noise and starts being the most fascinating mystery you've ever stumbled into. So if that sounds like your kind of thing, hit subscribe, because today's video is exactly what this channel is about. We're talking about the James Webb Space Telescope, the discoveries that are shaking modern cosmology to its core, and one Nobel Prize-winning physicist who says he saw all of this coming, because he believes our universe has died and been reborn before. Stay with me. This one gets wild. In January 2026, NASA confirmed something extraordinary. The James Webb Space Telescope had just smashed its own distance record, again. The galaxy is called MOM-Z14, and when you hear what it is, the name suddenly makes sense. It stands for most of most. It's the farthest and one of the earliest galaxies humanity has ever seen. Its light has been traveling toward us for approximately 13.5 billion years. When that light left its source, the universe was only 280 million years old. Think about that. The universe is roughly 13.8 billion years old. This galaxy was already shining brilliantly when the cosmos was barely 2% of its current age. And here's where it gets strange. According to lead researcher Rohan Naidu at MIT, this galaxy is brighter, more compact, and more chemically enriched than astronomers predicted for something so ancient. In his own words, with Webb, we are able to see farther than humans ever have before, and it looks nothing like what we predicted. Nothing like what we predicted. That's not a minor footnote, that's a crisis. MOM-Z14 is not alone. It's part of a growing army of what scientists have begun calling universe breakers. Galaxies so massive, so bright, so chemically mature for their age that they simply should not exist. In 2023, astronomer Mike Boylan-Colchin at the University of Texas published a landmark study in Nature Astronomy. He identified 6 early galaxy candidates spotted by Webb, each one observed between 500 and 700 million years after the Big Bang, and each one measuring more than 10 billion times the mass of our Sun. One of them appeared larger than the Milky Way itself. Our galaxy had billions of additional years to grow to its current size. These galaxies somehow got there almost instantly. Under our standard model of cosmology, called lambda CDM, or the dark energy plus cold dark matter model, this shouldn't be possible. To form galaxies that massive that quickly, the universe would have needed to convert nearly 100% of available gas directly into stars. But in the galaxies we observe today, that conversion rate peaks at around 10%. So either something is drastically wrong with our understanding of star formation, or something is drastically wrong with our understanding of the universe's history. Possibly both. Then in August 2025, researchers at the University of Missouri doubled down. They announced the discovery of 300 additional unusually bright cosmic objects from the early universe, an entire population of galaxies behaving in ways the textbooks say they can't. 300. This is no longer a fluke. This is a pattern. As if massive, impossible galaxies weren't enough, Webb has also poured fuel on a separate fire that's been burning in cosmology for over a decade. It's called the Hubble tension. Here's the idea. The Hubble constant measures how fast the universe is expanding. Our best theoretical models, calibrated using the ancient light left over from the Big Bang, called the cosmic microwave background, predict a value of about 67 to 68 kilometers per second per megaparsec. But when astronomers actually measure the expansion rate using real objects in the real universe, supernovae, pulsating stars, gravitational lenses, they consistently get a higher value, around 73 kilometers per second per megaparsec. That gap might sound small, but in physics, it's enormous. It's far too large to explain away as measurement error. Webb's most recent observations haven't resolved the gap, they've confirmed it. And some of the world's leading cosmologists are now openly admitting that the standard model may be missing something fundamental. Mark Kamienkowski, a cosmologist at Johns Hopkins, put it bluntly. The discrepancy could point to something entirely absent from our current understanding. A new form of matter in the early universe, unknown particles, or forces we haven't even theorized yet. Theorists, he said, have license to get pretty creative. There's one more piece of this puzzle that deserves its own spotlight: the little red dots. Over Webb's first 3 years of operation, it has repeatedly captured tiny, brilliantly red objects scattered throughout the ancient universe. In November 2025, researchers confirmed one of them, a galaxy called Canucks LRD Z8.6, contained a supermassive black hole actively feeding just 570 million years after the Big Bang. That black hole was growing far faster than our models say is possible at that stage of cosmic history. The lead author of the study, Roberta Tripodi of the University of Ljubljana, described the finding as truly remarkable. She said the discovery challenges our understanding not just of black hole formation, but of galaxy formation itself, and opens entirely new avenues of research. And in September 2025, another team proposed something even more radical, that some of these little red dots might not be galaxies at all. They might be a completely new type of cosmic object, something we have no name for yet. Let that sink in. After a century of modern astronomy, we may have just found something that doesn't fit into any category we've ever created. So where does all of this leave us? Is the Big Bang wrong? Or is the problem deeper than that? This is where Nobel Prize-winning physicist Sir Roger Penrose enters the conversation. Penrose has spent years developing a theory called conformal cyclic cosmology, or CCC. His idea is radical, but mathematically rigorous. Our universe is not unique. It is one in an infinite chain of universes, each born from the death of the last, in an endless cosmic cycle. Here's how it works. Our universe will keep expanding until all matter eventually decays, black holes included. Over incomprehensibly vast timescales, even supermassive black holes will evaporate, radiating away their mass as light through a process Stephen Hawking predicted. In the end, the universe is filled only with massless particles, pure energy, pure light. And at that point, Penrose argues, the geometry of that dying universe becomes mathematically identical to the geometry of a brand new Big Bang. One eon ends, another begins. But the truly stunning part of Penrose's claim? He believes he's already found physical evidence of the universe that came before ours. He calls them Hawking points, faint circular hotspots in the cosmic microwave background, the ancient afterglow of our own Big Bang. According to Penrose, these circles are the residual signatures of supermassive black holes that evaporated in the previous cosmic cycle, their last whispers carried across the boundary of one universe into the next. Penrose and his colleagues published updated analysis in March 2025, refining predictions about the size and temperature profile these Hawking points should display, and arguing the observational evidence remains consistent with CCC. Not everyone agrees. A rigorous 2022 reanalysis using machine learning found no statistically significant low-variance circles after accounting for bright pixel anomalies in the data. The debate is live and unresolved. But Penrose has heard skepticism before. Black holes were once dismissed as mathematical fiction. Now they're photographed in stunning detail. He's not rushing to stand down. Here's what all of this adds up to. In just 3 years of operation, a single telescope has confirmed that the universe contains galaxies too massive to exist, is expanding faster than it should be, houses black holes that formed too quickly, and may contain entirely new categories of cosmic objects we've never imagined. Something is missing. Something significant. Maybe it's our model of early star formation. Maybe it's an unknown form of energy in the infant universe. Maybe, and this is the wildest possibility, the Big Bang itself was not a beginning, but a transition. A handoff from a universe that came before. Science doesn't hand us certainty. It hands us better and better questions. And right now, the James Webb Space Telescope is handing us the best questions humanity has ever been asked to answer. The universe is broken, and that might be the most exciting thing that's ever happened in science.